So we are going to talk about 3E kinematic motion in a straight line. So the first important variable that you have to know is time. Time is a scalar quantity, and when you talk about times, so there are a few important words that you have to take notes of. The first word is, when they give you the word initial, you straight away know that it means t equal to 0. Okay? Are you clear? If they ask for initial something, you have to substitute the t equal to 0. Are you clear? Okay. Second important thing is, when the question asks for when is the object stop moving, for example. So when means you are looking for time. You must find the time. Okay. And what do you understand by stop moving? What do you mean by stop moving? Anyone here in the class? Okay, someone have answered me, say that when you stop moving means the velocity equal to 0. Okay, stop moving means the velocity equal to 0. Stop. Okay, so a lot of words in this kinematic, you must know the meaning. You must be able to write it in mathematical form. Are you clear? Okay, so that is talking about time. Okay, second important term, that is called displacement. What do you mean by displacement? Displacement, we use the symbol S. So it's always put in terms of T. Yeah, so displacement S means how far the object from a fixed point. On the straight line. And this fixed point, we always call it the origin. So that means it also gives you the sense of the position. Or I say where the object is on the straight line. At certain time. Are you clear? So if the question asks for position, the question asks for where, that means they are talking about displacement. So let's look at our examples. The one that is given. They give you the displacement function. That is ST equal to what? Do you have the question with you? Bram, do you have the question with you?
Yes, Miss.
Yeah.
2, 3 cube.
Good.
Plus 2 plus 3 square
Good.
plus
Minus. It's a
sorry,
minus. Minus 3060 plus 18.
Yeah.
And the unit is in cm. Okay, so this is called the position function. So if I set the question like that, what is the initial position? So what should I do with this question? If I say what is the initial position? What should I do? Shinyi, Nyo Shinyi.
Yes, miss.
Yeah, what should I do?
On 0.
So are you sure it's on 0? What is the initial? So when you see this word initial, what should you put T as? Shinyi,
TS.
what should you put T? What is the value of T when I have the initial? So what is the value of T? Of time. T is time.
0.
So that is the meaning of initial. So position is S. So what I do from here, I do S, I sub the T as 0. So for this one, I don't have to substitute manually. I can use my GC. So still remember your GC. So whenever you solve a problem solving question, your Y1, please everyone take out your calculator. Y1, key in this ST function. Please key in all this, and you don't key in as T, you key in as X. So when you key in your Y1, you key in as like that. 3x cubed plus 3tx squared minus 36x plus 18. Can you please? Everyone key in already? Okay. Key in already? Okay, so you quick from there, then you can get your S0, correct? You call out Y1, 0. Okay. Okay, Sihen, what is the answer?
18.
18, huh? Okay, 18 cm. So now I want to interpret this for you to know. Okay, what do I mean by 18 cm? We said this is a motion on a straight line, all right? So this is the straight line. You want to draw vertical also can. So I told you there is a fixed point. That is the origin. This is a fixed point. So when I say 18 cm, that means initially the object is 18 cm to the right of the origin. So that is the meaning of displacement. How far is it away from the origin? If the displacement is positive, that means it's here. 18 cm, the object is here. at the beginning. Are you clear? So if the displacement is positive, the particle is at the right of the origin. Okay, now, if t equal to 1, okay, the position will be S1, right? So where is the object after 1 second? After it moves for 1 second, where is the object? That is the meaning of this. Yeah. Okay, Nandini, Devi, you have your calculator. You should be able to give me the answer quickly. Nandini, Devi,
Yes, Miss.
what is the value of S when t equal to 1? You do second trace Y1. Please take out your graphic calculator, everyone. I ask you to key in. I give you time to key in already, just now. Anini, Devi, what is the answer?
Not sure, Miss.
You have your calculator. How can you say not sure?
I don't know how to do it, Miss.
What do you mean you don't know how to do it? Can you please tell me?
I don't know how to type it in the calculator.
You don't know how to type this into the calculator?
Yes, Miss.
Isn't it too much? Okay, Christopher, can you tell me what is the answer for this one?
Negative 13.
Negative 13. Is that correct, class?
Yes, Miss.
Negative 13 or negative 26? Negative 13, okay. Negative 13. Okay, negative 13 cm. So this negative, okay, positive represent right. Negative will be what? Left of the origin. So after 1 second, the object is 13 cm to the left of the origin. Okay, I don't know how the object travel, but I know that after 1 second, the object is here. Are you clear? So they just tell you where is the object, position of the object on this straight line. So now you understand the meaning of displacement? Hello? Okay, first one, second one. Then we are going to the third one. Third one, we are talking about velocity. Velocity.
Miss,
Yes.
is it okay if you go to the previous slide for a bit? Just one screenshot. Thank you.
Okay.
Done, Miss.
Yeah, velocity is VT. Okay, what is velocity? Velocity is the rate of change.
I didn't tell you I was supposed to do the earlier one. Sorry.
Hello? What is
Just
the
me.
problem?
No, I didn't finish writing off the previous slide, sir. Nice.
You see how your friend do? Screenshot.
Yeah, sorry. Yeah, I was writing down, miss. That's why. Okay, I'm good, miss. I'll just take a screenshot anyway.
You are mumbling there.
No, miss. I took a screenshot.
Okay,
instead,
okay.
So yeah.
Okay. Done?
Yeah, I'm done, miss. Yes.
Okay. Velocity is the rate of change of displacement. That means the st. So velocity is s prime t. Clear? So we have our st, which is two t cubed plus 3t squared minus 36t plus 18. Okay, listen. This, your st is in y1, correct? You key in like that. And so on. This is your st, am I right? So your y2, in your graphic calculator, you are supposed to put like that. Am I right? The derivative. So this one will represent your vt. Clear? Okay. But if we differentiate it manually, bring down the power, power take away 1. Bring down the power, time by the power, power take away 1. This is negative 36. So it will be cm per second. So if the question asks, what is the initial velocity? So what should I do? What should I do if the question asks for initial velocity? Rachel.
Is it t equals to 0?
Okay, sub into which one?
Sub into t.
Yes, sub into VT because I'm asking for initial velocity. So I'm asking for when t equal to 0, what is the velocity? Right? So I got it from my y2. So can you tell me what is the answer? Chunyi or Amanda?
Negative 36.
Yes, so negative 36 cm per second. So how are we going to interpret this? What do you mean by negative? That means I'm saying that initially the object is moving to the left. With the speed of, so the magnitude is the speed of 36 cm per second. So just now, if you talk about the motion in the straight line, the object is here, 18 cm. Now I know this object is moving to the right, to the left. And the speed is 36 cm per second. See or not? It is at the right of the origin, but it is moving to the left. That means it's moving towards the origin in this case. Depend on the case. Are you clear? So the sign of the velocity tell you the direction of motion. So everyone must remember the sign tell you the direction of the motion. The magnitude is the speed. Are you okay? Anything else you want to ask? So if I ask you this question, what is the velocity of the object when it is at the origin. So what am I going to do? If you want to find velocity, you must have the time, am I right? Because all this function is in terms of time. So how to find time? So what does this mean? When it is at the origin. So you have to start to solve this problem by knowing what is the meaning of this one. So all these questions are like that. You want to start to solve the problem, you have to see the information given in the question, the last information. So what do you mean by it is at the origin? Can someone tell me? When the object is at the origin, how far is it away from the origin? How to?
How far?
How? So I will ask question like that so that I can solve. How far is the object from the origin?
At initial time.
No, I say it is at the origin. How far away is the object from the origin? Yeah, yes?
0.
Yeah, do you know that?
Now
If you
no.
don't ask this question, do you know that? You don't know. So that means you have to start with this information. You have to start to work like that. So S T equal to 0. So can you find T? Can you find T? You use your scientific calculator, please. Can someone use your scientific calculator and find the time? Hello? Okay, so I'm going to call you idea. Who is the lucky one? Okay, shall we?
Yes, miss.
Yeah,
Wait, still trying.
you use your scientific calculator. Do you know how to use it? Your young people, you are working very slow. Okay, Xin-Chi. Xin-Chi, can you give me the answer?
3.22.
3.22. Another one?
Negative something.
Cannot be, no? It should have 2. The other one should be 1 point something. No, the other one should be 0 point something. Yeah, 0.532. 532. Okay. So that means first you see here, if you look at my this diagram, it come here. So the first time it passed through the origin is 0.532. Then it go. Then after that, somewhere it turn back. Then it come back here again. So you see, I can imagine the motion of the particle already. Right? So why I know it's like that is because, okay, so now I call out my Y1. So I can get my V. Can you use your Y2? Can you use your Y2? This is GC, you call out your Y2, then you key in 0.532. So I record down in my book V 0.532. Can someone give me the answer? Ian, Ayman? Ian? Ian, Ayman, are you here?
Hello?
Hello, yes,
Yeah, I got
answer.
negative 31.1.
Negative 31.1 cm per second. So you see, it's moving to the left, right? So can you get your V 3.22? The velocity when it's after 3.22 seconds? Madeline?
45.53.
Thank you. 45.53. Okay, 5 cm per second. Okay, so you see it's moving to the right. Okay or not? Here. When it comes to this part, it's moving to the right because the velocity is positive. Got it? So you must know how to interpret a lot of terms here. As we move along, we will learn. So now you understand the velocity, huh? Okay, when stop moving means velocity equal to 0. If I ask the question, when is the object stop moving? When is the object, instead of say stop moving, when is the object changes its direction of motion? So if you look at this diagram, at first it's like this, then it had to stop first, then it changed the direction of motion. So if you want to talk about when, that means you are talking about time. When the object changes its direction of motion, so you have to remember that changing direction of motion means it must stop, then only change. Correct? So you have to put Vt equal to 0. Okay, do you have the quadratic? Can someone using your scientific calculator and tell me what is the value of T? Jen, how? This one equal to 0, huh? Solve the quadratic equation. Jen, how? What is the answer?
Got 2.
Yes?
I got 2.
You got 2. Actually, the calculator will give you 2 answers, correct?
Yeah.
T equal to -3 and T equal to 2. But we know that time cannot be negative, correct? T must be greater than 0. Therefore, T equal to 2. Okay? So, okay, whoever want to screenshot, better screenshot now. Can I continue? Hello? Can I continue?
Yes, Miss, you can.
Okay, I can continue, huh? Okay, so now, it stop doesn't mean you have to change the direction of motion. It can stop, then go on again. Like for example, if I go back to Malacca, okay, I drive. I stop at the rest place, but I still continue with the same direction, correct? So how am I going to prove that it changes in direction of motion? So I draw the sign diagram of Vt. And what should I mark here? 2. Then you can use your graphic calculator Y2 to help you to determine the sign. This is negative, this is positive. So I conclude the object changes its direction of motion at t equal to 2. Okay, so that is done with velocity. And I also can, based on this velocity sign diagram, I also can make some conclusion like that. For t between 0 and 2, the object is moving to the left. Okay, then for t greater than or equal to 2, the object is moving to the right. So if the question asks, when is the object moving to the right? Then you have to draw the sign diagram of VT to answer this question. Okay, done? 1, 2, 3, done. The fourth one, we talk about acceleration. Acceleration, we use A to represent it, is the rate of change of velocity. So it means that acceleration is v prime t, or it is s double prime t. Okay, so in this sense, that means you are talking about like inflection point and so on. Yeah. Okay, so for our case here, our VT is 6t squared minus plus. Can someone give me the answer? Plus 60 minus 36, correct? Okay, so you want to find the acceleration, you have to differentiate the velocity. So you have 12t plus 6. Okay, now, so for this case, actually the acceleration is always positive. Why? Because t is greater than 0. So at 12t definitely will be greater than 0, right? So 12t plus a number definitely will be greater than 0. So therefore, I can conclude at is always positive. So if at is always positive, this implies that the velocity is always what? Increasing. If the velocity always increasing, does it imply that the acceleration is always increasing? And does it imply that the speed is always increasing? The answer is a no, because just now we look at here at the beginning. The velocity is, the speed is 36 cm per second, right? Then at the origin, the speed is become, the velocity is what? At the origin just now. What is the velocity? The velocity is negative 31, correct? Velocity is negative 31. So velocity is negative 31. So it moves to the left, negative 31. So you see from negative 36 to negative 31, isn't it increasing? But you look at the speed, is it increasing or decreasing? Decreasing. Then until certain point at t equal to 2, it stopped totally. Velocity equal to 0. Correct? You see, from negative 31 to 0, isn't it increase? But the speed is 0. So bear in mind, velocity is always increasing. It doesn't mean that the speed is always increasing. Depend on the situation. We will talk about that in our question. Hello, class, are you okay? Okay, Anna? Okay, so now you understand all this already. We are going to answer that particular question, question 1. Then you have to try question 2. And tomorrow I will discuss question 2 and the whole exercise 3E. Yeah. So now let's go to our question 1. So now we answer properly. Okay, so now you key into the calculator. Everyone should have this in your calculator already. Okay, everyone should have this. So we answer part 1. Find the velocity and the acceleration function. So we find the velocity function. 60 squared plus 60 minus 36 cm per second. Okay, then after that, they want us to draw the sign diagram. So any sign diagram that you want to draw, first you must find what is the value that will make the variable equal to 0. So just now, we found that we use our scientific calculator. We said t must be greater than 0. So therefore, t equal to 2. Correct? Okay, then we draw the sign diagram. In the exam, SAT 2, you sure got one question like that, and this will give you 2 marks. You get the velocity function 1 mark, you get the sign diagram correct 1 mark. So everything is done by the calculator so that you can be fast. Done. Okay, then we continue with the AT function. 12t plus 6. Okay, then we put AT equal to 0. So which means 12t plus 6 equal to 0. So t must be greater than or equal to 0. So therefore, no solution. Okay, so I draw my AT sign diagram. Always for kinematic, because it involves time, so it must be 0 onward. So it's a plus. Done, you get 4 marks. Okay. Then after that, they say find the initial position. So when they say position, okay, I have 3 functions here. So you have to know which function must I use. So if I ask for initial position, I know that t must be equal to 0. So which function should I sub into? Which function should I sub into? Chokan. Blue, black,
ST.
or huh?
ST blue.
Yes, the blue one. Yeah, so S0. So you can use your graphic calculator straight away, put down there 18 cm. If they ask you to interpret, you should interpret like just now how I interpret. All right, but they didn't ask you to interpret, so you don't have to. Okay? So then we go to part 3. Part 3 say that find the initial velocity. So initial t equal to 0. So which one I should sub into? Initial velocity. Raisa,
VT, the black.
thank you. Yes, you are right. So that is negative 36 cm per second. All right, then you interpret. If they ask you to interpret, you say the particle is moving to the left with the speed of 36 cm per second. Okay, part B. Same thing, using your graphic calculator. V4. Okay, can you tell me what is V4? Someone, please key into your calculator and get the answer straight away. Wen Cheng? Well, your Y2.
84.0.
24.0.
84.
84, thank you. 84.0 cm per second. Okay, I don't want to see your substitution. Okay, done with number 3. Number 4. Can someone read the question number 4 to me? Sandhya?
Find the time and the position when the object reverse direction.
Yeah, so the keyword is reverse direction, correct? Reverse direction. So this word reverse direction is telling us the information what? V what equal to Vt equal to what?
0.
Vt equal to 0, yes. So we from part A, since we got, so we just can say from part 1. T equal to 2. So have we finished answer the question? No, because they say the position. So what should I do after this? If the question asks, time I got already. The particle reverse its direction of motion 2 seconds. So then what should I do next? If the question asks for position, what should I do? Serini. Serini?
Yes.
Yeah, what should I do? They ask for position.
Draw the sign diagram.
No, they ask for position. That means they ask where is the object. At 2 seconds. I'm asking this. If I ask for position, means I ask this. Where is the object? At 2 seconds. So which one should I sub in? I got 3 functions there.
Oh, sub the 2 into VT.
Cannot. VT is direction and speed. Position. So you have to memorize by heart.
T.
Which one? Yes?
Sub
Yeah,
the 2
yeah.
into ST.
Yes, you are right. So you S2, you straight away use your graphic calculator. So can you give me the answer? Y1.
Negative 26.
Yes, you are right. So you see, this chapter is very important. If you don't memorize all this, I cannot help you at all. Okay, done with number 4. Got it? Okay, so we are done. So number 5. Find the time when the object speed is increasing. Okay, listen here carefully. So when you want to determine the speed, changes of the speed, you must have both Vt and AT sign diagram. And the way I make a conclusion is like that. Same sign, speed increase. So look, so opposite side decrease also, I don't have to write down that. So my VT sign diagram is like that. Negative, positive. Yeah, just now I show you in this diagram, correct? Look, from 0 to t, the velocity is increasing, but the speed is decreasing because the sign diagram of VT and AT have the opposite sign. Correct? So you see? So I say increasing speed, same sign. So the cutting point is here. This part have the same sign. So therefore, I make a conclusion. Make a conclusion. What is a conclusion? They ask, find the time when the object speed is increasing. The object speed is increasing from t greater than 2. Done. So there's no other better way. So you have to have both VT and AT sign diagram on top of each other, and remember, same sign, increasing speed. Okay, so for number 6, show that the velocity is always increasing. I have shown it here. That is how you show. Are you okay? So number 6, I'm not going to write again. Yeah. Okay. So number 7, find the acceleration of the object. And this one is very, very simple and straightforward. So you use your Y3 and you get the answer. If you don't want, the thing is simple enough. Yeah. Am I doing the right thing? Right? Okay. So part A, this is very important. Do you have a class after this? Okay, never mind. I just try my best to finish. Okay, find the total distance traveled by the object in the first 3 seconds. So what is the meaning of first 3 seconds? This means during this duration of time, from t equal to 0 to t equal to 3. That is the meaning of first 3 seconds. So now, every time when I give you a duration of time, you must ask this question. During this period of time, does the object stop moving? So, yes or no? Yes or no? If you look at the sign diagram, you know yes. Correct? We know because V2 is equal to 0. So it does. So that means we have 3 very important positions that we must find. So the first one is initial position. or I call it a starting position, initial position. That is S0. And just now we found it, it is 18. So if you have a graphic calculator, very easy. Then after that, we have to find the stopping position. That is S2, which is negative 26. Then we have to talk about the ending position. Where is stop? Where is we want to study end? Ending position, there is S3. Okay, can someone give me the answer? Can someone give me the answer? Yes, thank you. Negative 9 cm. So from all these positions, I'm going to draw what we so-called very important. We call a motion diagram. Because sometimes in the exam, we may ask you to draw the motion diagram. So motion diagram means this is a straight line. This one represents the displacement. This is the origin. Start here. You can draw. So it start here, then it start to move to here, correct or not? Then it reach here, negative 26. So you start with this is the first position, second, and third position. So first position is here, then second position is here. Okay. Then from here, it will turn. Then it come to here. So this is called the motion diagram in the first 3 seconds. So now the total distance traveled from here to here is 18. From here to here is 26. From here to here is 26 minus 9. Am I right? So total distance traveled, just write down the answer. Equal to 26 plus 18 plus 15. No, 17. Then you got the answer. So when you talk about here, we are not going to follow the method that you have learned in your Form 5. So for this chapter, very important. All the word that I tell you, you better know the meaning. Can or not? So you may want to watch this video again. Yeah. Okay, thank you, class. You have to go for the other class.
Thank you, Miss.
Thank you, miss.
Miss.
Thank you, miss.